trying to switch to another picture, but
focus for PowerPoint, right? There we go.
All right, thank you. Thank you very much. So nice to see so many international visitors here in Gothenburg, and a day like this with snow and everything. I heard that we have visitors all the way from Australia, so this must be something special for them. And I can see that there are quite a lot of listeners on digital media as well, so I say welcome to Gothenburg. My name is Ola Setterby, and I'm head of the GIS department at City Planning Authority in the city of Gothenburg. And I'm here to talk about a project we call the city of Stockholm and Malmö, and also Lund University. And it's been financed by the Swedish innovation program, Smart Built Environment, from the Swedish government. The title of the presentation is 3SIM, a Swedish path towards harmonized 3D geospatial standards. And even a person from UK have hard to pronounce it. Then I guess I will try to speak more whatever. Let's continue with the speak. So the aim of this project is a bit simpler. It's to develop a common information model that serves as a basis for a digital twin of the city. And I would like to add that it's, among other things, it's not only for digital twins, but as we put the bar quite high and aiming for digital twins, we solve a lot of other issues on the way. And why 3SIM then? We aim to solve three important problems, and the first one is to coordinate the geodata within our cities. I will talk about that a little bit later, and the second one is coordination of geodata between cities, and we also have in Sweden outdated spatial data models that were developed a long time ago that we still use in GIS and so on, and we try to find a solution to that as well with this project. More about these problems later, but I first would like to talk a little bit about the challenges that we face in Gothenburg and also other cities, of course. This is some sort of vision picture of Gothenburg. It's actually from our digital twin. The white parts in the picture is the city of today, and the different colored parts are city development projects in the near future. And the red parts are going to be built in a few years' time. The orange parts are further away, and the yellow is further away in the future. Actually, the picture is a little bit old, a few years ago. So some parts is already built. For example, the Kala Tower on the left-hand side of the picture is already standing there. And over these decades, the development is planned over an area of both sides of the river, spanning about 5 million square meters, and we call this the River City. And central Gothenburg, this area will double in size during these decades. And of course, that is a big challenge to handle all these development projects. We have also other challenges, more of societal characteristics. And these are, of course, challenges that you face in all cities in the world. Like climate change, for example, is something that is, of course, very crucial for us, as Gothenburg is a coastal city. And we have, we also actually face problems with the flooding and heavy rainfall and so on. And predictions say that it will be more often and heavier in the future. So that's something that we have to take care about. We recently had this pandemic that you all know about, and I think we all realized how vulnerable our society is when we're not prepared to something like that. And that's also something that we try to do preparations for, so that we build a more robust society. And Gothenburg is a segregated city, unfortunately, and that's also one of the main issues to work with. So that's a key challenge that we have to work with in our urban development and social development projects. Transportation is also a big issue for us. The city is growing, as I told you, and the city is getting much denser, so we have to move people and goods and so on in different ways than today, and that's a big challenge. And not least, we in the society produce, there is a rapid growth of the amount of data that we produce in the society, and that is of course both a challenge and an opportunity for us. And we have a lot of issues around data security and stuff like that, of course, that we need to handle in this area. So that are some of the challenges we face today, and how do we meet these challenges? I think we all agree that to be able to meet these challenges, we need to understand our cities. And to understand our cities, we need a lot of data. And we need to collect that data. It can't be data in different isolated places. We need to connect them in some way. And our way to try to connect and work with the data is building a digital twin of the city. We call it Virtual Gothenburg. And in Virtual Gothenburg, we want to be able to do tests and scenario studies and different sort of analysis, so that we can test development projects before we actually build it in the real world. And all this is about data, as you know. And I used to try to explain the correlation between data and digital twins with an iceberg. And if you look at the upper part above the sea level as the digital twin, and underneath is all the data associated to it, you can understand that we can't build up the digital twin without a lot of data underneath. And unfortunately, in most municipalities and other organizations, we have a wide range of databases and systems that cannot talk to each other. And if the data is not connectable, we can't build that digital twin on the surface. And 3SIM is our way to try to solve this. It's our way to try to connect these different data sources to each other. All right, and we also have these problems not only within our cities, but also between our cities and municipalities. In Sweden, we have 290 municipalities, and as all these municipalities have developed their own digital databases for geospatial information, especially the large-scale information described in the cities, we literally have 290 different data models. And of course, that is a problem, especially for large building projects covering many municipalities and companies and organizations that work within different municipalities. That's a big problem. And we also have vendors that provide us with software that need to adapt to many different data models, and that's also a problem, of course. I'm happy to say that we have started an initiative this autumn, actually, together with the National Survey of Sweden, with in-depth workshops and looking at 3SIM, if that can be a basis for national specifications for large-scale geodata. And that may be a solution to this problem. We are in an early phase, but I'm very optimistic about it, actually. It feels really good already. And while we're working with connecting data in Sweden, of course, we realize also that data doesn't stay in Sweden. We have to look internationally. We have to look at our neighbors, our neighboring countries, of course, and we also need to look at how we can connect data to other countries, and both in Europe and the world. And that's why we started with looking at what initiatives are there already out in the market internationally. And we found the CityGML specification. I'm in a place where I think that many of you already know about this, so I will not talk a lot about CityGML, but it's international OpenGIS consortium specifications for city models. And for us, that was a very good start. We choose it partly not to start from scratch with this specification, because a lot was already there, and partly in order to get connections to international data, and of course also support to different GIS software. Many GIS software have already developed readers and writers for CityGML, and in that way we can use that. And also, before talked about a little bit about outdated data models. In all our municipalities in Sweden, as I told you before, the data models are built up a long time ago, and then we have tried to add things to them to make them work today, but they are actually designed to solve the needs of that time, and based on the technology that was available by then. So when we started this project, we started with an in-depth investigation of what do we really need our data for? What challenges do we need to solve? And so we tried to use this opportunity to develop a new information model that, with a flexible design, to support the needs of today and the future. So what is 3SIM then? The abbreviation 3SIM is for 3D City Information Model. And this is a picture of a street in Gothenburg, Linnégatan. And this is the same street in our digital twin. But we don't stop with a visual representation of the city. It's very important in order to do all analysis and scenario studies and stuff like that. We need to be able to connect data to all these objects. So all trees, all buildings, all streets, and so on, everything are objects that is available, that has data connected and unique identities to be able to connect it to other data sources. That's, I would say, the key of 3SIM. 3SIM is built upon CityGML 2.0, but we have also made some extensions to it. And you can see all the themes in CityGML there, and a small orange dot on those where we have made some extensions. For example, bridge, buildings, city furniture, land use, transportation, tunnel, vegetation, and water body. And we actually also added an extra theme called utility. Utility is where we store utility networks such as water, sewage, and electricity. And this is to alter to add things to the specification so that it suits the needs of Swedish conditions. So you can say that 3SIM is what you call an application domain extension to CityGML. And ADEs are supported in CityGML, so that makes it convenient for us to work with CityGML as well as a base. Yeah, we can continue. But this spring, I think it was, I'm not perfectly sure about the date, but the 3SIM or the CityGML version 3.0 was released. And of course, that's an interesting improvement in the CityGML standard. But as we started the project, 3SIM 3.0 wasn't available, and we wanted to use a stable version. So that's why we have developed it up on 2.0. But during the project, we saw that there were some things in the 3.0 that we really would like to add in 3SIM. So we have actually took some parts from 3.0 and added that in our application domain extension. For example, section and intersection in the theme of transportation, and versioning in the core class of the specification. Versioning is important to be able to work with historical data and future data, and that's very important when you work with city models. So we wanted to add that. Another important decision we made early in the project was that 3SIM must be a thin information model. With a thin information model, it means that we don't store a lot of information in the actual 3SIM specification, but we make sure that 3SIM is possible to connect to other systems and databases where you have much more information. For example, connected to specific systems about parks, environment, buildings, tunnels, water, traffic, bridges, and so on. And on the right-hand side here, you see an example where we make sure that the surfaces of street data in 3SIM correspond to the links in the national road database. And in that way, we can have an easy connection between them and use all the attribute data from the national road database in our analysis with 3SIM data. This is a picture of the UML diagram, a bit technical maybe, but I just wanted to show you that we have tried to be very clear about what parts are actually plain CityGML and what parts are specific for 3SIM. So we have pointed out with the notes where you have added parts in our specification. So for example, in traffic area, I can see that there are two attributes added, and the class marking is completely new in the transport theme for 3SIM. In order to use this, we wanted to have a technical specification, a technical solution. So we have used the 3D City database, which is based on PostGIS. The choice was quite easy, as this is an open standard already developed for CityGML data. And in that way, any other municipalities in Sweden can download the database and our specification and start working with it. We have also added some extra parts, so we have developed the importer and exporter tools to this database in order to support the 3SIM standards. So you can import 3SIM data directly into the 3D City database, and you can export it in different formats like CityGML, KML, Collada, GLTF, and CityJSON. In the project, we also had some test applications to make sure that the 3SIM model actually functions for what we want to use it for. For example, daylight simulations, wind simulations, and noise simulations. And it turned out to function very well, so we are very pleased with it so far. And among others. And I also wanted to mention this one. You will get some more information about that later from my colleague Erik. This is a European Union project, European Cityverses Uniting for Inclusiveness, or shortly the CU project. And in this project, we needed an information model for accessibility information. As we are working with our other cities and universities in Europe, the Gates University of Sofia was responsible for this information model. It was very easy for us to tell them that make the accessibility model as an application domain extension to CityGML, and they can just start working. And we are sure that this will be compatible with our data in Sweden in 3SIM formats. So that's a very good way of working with other cities internationally. But you will hear more about that in the next speech. So that's about it. And if you want more information about 3SIM, you can click on these links. 2 links to the Smart Built Environment page, where we have the documentation and so on. And we also have a lot of data on the GitHub. You can download test data, and you can download the XSD files and more technical specifications and so on. I guess that we get the presentation afterwards. Yep. So thank you very much.
That's a great start to the day because you're actually on time.
So perfect.
I like the CityGML, and you're actually thinking about CityGML 3. I've got friends in the standard world who like CityGML 3, so yeah, they'll be pleased.
I also like it.
Yeah, no, that's good. That's well received. So yeah, that's great. Does anybody have any questions? Question at the back there. There's Jan.
Thank you very much. My name is Jan Hjelmer from Denmark. Actually, I have 2 questions. The first one is regarding utility. Have been looking towards OGC's MUDI project for underground infrastructure. That was the first question. My second question was the model where you have the 3SIM and then you have all the domains around it. Has that required some changes in the other domain models before, in order to be able to incorporate it into 3SIM? Thank you.
I think I answered the second question first. Our dream, of course, is that the other systems that will look at 3SIM as we want to connect our data to 3SIM, and that's why we have to add the unique IDs in our databases. But we have to be realistic. Those systems are already there, so we do the opposite in this version. So we have the possibilities to store unique identifications for their systems instead. And in that way, we do the connections. And the second question was about underground data. And that's a very detailed question. And I don't know really if we have looked into that part. It's I don't think I can answer that question actually, but there are people who have been working with that theme more in depth that maybe can talk about that. Maybe Erik can answer. Do you know?
Okay.
So.
Okay, so actually in the UK, we've been using the MUDI conceptual model to create an underground asset register, and we've covered the whole of the country with that. And its sole use case was to avoid strikes, because they were a real financial burden. But I can see with what you've built there that could probably be put on.
I can tell you as well that as this is quite a lot of work with this model. We have focused, in the first way, we have focused on things above ground. Yeah. And actually the parts that are below ground, sometimes they're quite sensitive. You can't really show everything underground. So maybe we have probably a lot more to do underground that we need to continue to work with in the future, I would say.
Any other questions? Another one.
Hello, good morning. I'm Dr. Didatta from India. Yeah. It seems that the 3CIM is a meta model, like, it's because you say that then it's related to all those thematic, the operating systems, because you said the 290 municipalities. So are you trying to, again, standardize the thematic, the operating systems, or are you using the 3CIM, like 3CIM as a meta model to link them to and standardize the CityGML? Because that's a challenge, like any this type of a municipality system will face.
Actually, good question as well. We are not aiming to link them with the municipality data. We are more hoping that all the municipalities of Sweden see the benefit of have a common specification for all municipalities in the future. And that's why we also have had in-depth discussions with the National Survey of Sweden. So, and we hope for national specifications and that our municipalities will adapt their data to it. But many municipalities have different data models for collecting data and for delivering data. And here I would say we're more talking about the deliverance of data. So you can still collect data in a way that you are finding the most suitable for your municipality. But when you deliver it, we need some easier way to connect data to each other, and that's what we hope that 3SIM and the national specifications will help us do that.
Okay, thank you very much.
Thank you.